Hey y'all, let's go ahead and start talking about notes on section 2.13A, exponential and logarithmic equations and equalities. So we're just going to be focusing on equations for this section. So remember, if we're looking at example number 1, remember, if we have a log of some base on both sides, okay, if these bases agree, then we can say, well, whatever b is must be the same as c because of those same bases. So let's look at this example. We notice here we both have log base 3, log base 3. We learned in our previous section, this is the product rule. So we can write this all as one base, where it's a base log 3 because they're both a base of 3 on that log. And by using the product rule, I can say this is really equivalent to x times x plus 7 on the left side. What happens here is now I only have one log. And now I have this rule that we just talked about, that if you have two logs with the same base, which we have here, then we can set these equal to each other. So then x times x plus 7 equals 60. Well, I know that x times x plus 7 is just x squared plus 7x. Now I just need to solve. This is just a quadratic, so let's subtract that 60 over so we can set it equal to 0. Because anytime we solve the quadratic, we have to set it equal to 0. So let's subtract that 60. We get x squared plus 7x minus 60 equals 0. Either we can factor this or use the quadratic formula. If we factor this, we need to see, is there anything that multiplies to negative 60 that will add to 7? I know that 12 times 5 multiplies to 60. To make it negative, we can make that negative 5. This will work. So we can say x squared minus or plus 7x minus 60 can be factored to x plus 12 times x minus 5. If you didn't remember how to factor, you can always use the quadratic formula. Once we do this, we know we can use the zero product property, where we can split these up. X plus 12 equals to 0 and x minus 5 equals to 0. Therefore, x equals negative 12 and x equals positive 5. Remember, though, that as we plug things in, we have to go back to check for some extraneous solution. So if I were to plug this back in, this would give me a log base 3 of negative 12. Remember, we can't ever take the log of a negative number. So this is an extraneous solution. But if I plug in 5 into both of those, here and here, it will work either way. So this is our solution, x equals 5. Let's look at example number 2. It says, solve an equation with logs and constants. So let's see what we've got here. We've got an example where we have to solve, we've got two logs, both have the same base, and we have a constant here. What I see I can do is I can move this log over to the other side so that both logs are on the same side. So let's go ahead and add log base 2, x plus 7 to both sides. So what that leaves me here is 3 on the left side, and we got log base 2 of 5 plus log base 2 of x plus 7. So just like on the previous example, I have two same base logs. I can use the product rule and rewrite this as simply one log, and this becomes 5 times x plus 7. So now to solve this, I need to get rid of that log. So we're going to remember that one of the ways that we can use a log is that we can use those identities of logs. And in order to cancel the log, we are going to use the identity that if I have a base raised to a power of a log of the same base, that base and that log will cancel. So because I have a log here, I know that if I raise it to a base of 2, that will cancel out. So whatever I do to one side, I'm going to do to the other. So I'm going to raise both sides by a number of 2. So these now cancel. So this is 2 to the third equals 5 times x plus 7. If I simplify that, that's 8, because 2 to the third is 2 times 2 times 2, equals 5x times 5 plus, plus 5 times 7, which is 35. And now I'm just going to use algebra to solve this. Subtract 35 to both sides. This becomes negative 27 equals 5x. Solve x by dividing x on both sides, or 5 on both sides. So we've got x equals negative 27 over 5. Okay. And if you plug that back in, it works no problem. Let's look at the next one. So we're going to use logs to solve these exponentials. So we see here, the problem is I'm trying to solve for x, but it's in an exponent. And we know when we are trying to get something out of an exponent, you can use a log to get it to go away. Before we do that though, let's do what we can. Let's get rid of this coefficient of 3, so divide by dividing by 3. So this leaves me with 2 to the x plus 2 equals 4. To get this x out of the exponent, we're going to reduce it by using that the identity that says that log of some base of the base number equals its exponent. So this part will cancel. So because this base number is 2, I'm going to take log base 2 of both sides. This will cancel that 2. That leaves us with x plus 2 as this exponent comes down, and we get equals to log base 2 of 4. We can solve this. I also know that log base 2 and 4 have a special relationship. This 4 can be rewritten as 2 to the 2. And we remember log base 2 of 2 cancels. So this is on the right side 2 equals x plus 2. Solve for x by subtracting 2 on both sides, and we get x equals 0. Plug it back in and it works just fine. Example 4, this time we're going to use some technology here. So instead of solving this by hand, we are going to use our calculator. So this I'm going to have be our y1, and this is going to be our y2. To see where they equal to each other, we're going to find where they intersect. So take out your calculator. I'm going to show you how to do that here. Take out your calculator. And I've got 1 in 9, but you're going to go ahead and go y1 equals log of x plus 6, close your parentheses, plus 3, and y equals 2. Go ahead and graph that, and we can see both of those graphs. Now, in order to find that intersection, we're going to hit second trace like we've done before. Go to option 5 to intersect. And then it's going to ask you some questions here. It says, hey, is this the first curve? Meaning, is the cursor on one of your curves? Yes, it is. So we're going to hit enter. Is the cursor on the second curve? Yes, it is. So hit enter again. We're going to see where they intersect, and we get an intersection at x equals negative 5.9. So we're going to say x equals negative 5.9 is our intersection. Okay. All right, we're going to keep going from there. Next page. So this is where you get to try these on your own. Push pause on the video, try them on your own, and then come back and see if we got the same thing. I'm just going to remind you that when you see ln, that's the same thing as a log base e. All right, go ahead and push pause and see if we can get the same thing together. All right, let's go ahead and try these and see if you got the same thing that I got, okay? So looking at this, because I know that an ln is really a log base e, I can either rewrite it, or I know if I raise this by an e, that will cancel out my ln. So I'm going to do that to both sides. This now cancels. So we have the root of x minus 12 equals e to the 4th. Well, to get rid of that root, I'm going to square both sides. So then this is x minus 12 equals e to the 4th to the 2. Use your power rule. This is really e to the 8th. To get x by itself, let's add both sides by 12. And we get x equals 12 plus e to the 8th. Plug that in your calculator, and you get x is approximately 2,992.96. Hopefully you got that one correct. On number 6, let's go ahead and solve for x. Remember, x is in your exponent, so we're going to have to get it out. Let's deal with this 9 first, divide it by both sides. So we end up with 1/27 to the x over 3 power equals 9. So remember, because that x is in the exponent, we need to get it out of the exponent. So I'm going to take a log of this 1/27 as the base. So if I take log of 1/27 on both sides, this is going to cancel out here. So we're left with x over 3 equals log base 1/27 of 9. To solve this, we can put this in the calculator. You can either use it directly or use the change of base. Let's go ahead and do that. Here's my calc. All right, so we're gonna clear out of this. We're just gonna go to second quit to get back to your regular screen. So we're gonna take the change of base, or you can use math option A. That's my log base. So this is gonna go 1/27 in the base of 9, and we get approximately negative 0.666667. We know that that's negative 2/3. So x over 3 equals negative 2/3. You can multiply both sides by 3 to get that out of the denominator of x. So we get x equals negative 2. All right, and then the last one, we see here that all of these are log base 10 or a common log. So let's use that product rule to combine. Now that I see that we have the same base on both sides, you can raise both sides by that 10 and it will cancel both sides. So we can say 3 times 2x is 6x, 3 times 7 is 21, equals x plus 6. And now we're just using algebra to solve. Subtract the x to both sides, subtract the 21 to both sides, and we get 5x equals negative 15. Divide both sides by 5, and we get x equals negative 3. If you plug that back in, it works no problem, no extraneous solutions. Hopefully you got the same thing, and I will see you back in class to do the practice.